We're going to talk about the last type of system solving, and it is called elimination. So if you'll look at this system on the side here, it says, what is the sum of these two equations? Now remember, when it says sum, we're going to add them. So if we think about kind of like in elementary school when we added vertically, so I can see that 6x minus 2x is 4x. My 4y minus 4y becomes a 0, and then 8 plus 0 equals 8. So when we come back over here, what was the sum of the two equations? Well, those y's ended up canceling, so we just have 4x equals 8. What happened after that? Well, we can say that the y's eliminated. Thus the name elimination. List the variable that remained. So if we take 4x and its value, so 4x equals 8, and we divide by 4, we get that x equals 2. If Nikki knows the value of one variable, how can we find the value of the second one? So this goes back to what we did in substitution, those last two steps. So we're going to just, now we know one of them, so we're going to substitute into one of our original equations. Now they want us to actually do that and find that value. So it doesn't matter which one you use. So I'll just use this first one. So if I say -2, my x is 2 plus 4y equals 8. So I have -4 equals 4, plus 4y. Careful with your signs there. Equals 8. We know we got to add 4. Add 4. 4y equals 12. So y is 3. So now when we do that, we can find that our solution is 2 for x and 3 for y. Substitute these in, and that's how we can check it. So my first equation, -2, instead of x, I'm using 2. Plus 4 instead of y, I'm using 3. Equals 8 when I put that into my calculator. Or if I solve by hand, -4 plus 12 is in fact 8, so that works. And then the second one, 6 instead of x, I'm using 2. Minus 4 instead of y, I'm using 3. Equals 0, and I get 12 minus 12, that is in fact 0. So we're still checking it the same, it's just that first step that's a little bit different. So in order to do elimination, we are going to line up our like variables. So if they don't already line up, we're going to need to make them line up. We're going to combine, so we're either going to add or subtract, and the goal is in fact to eliminate a variable with the opposite coefficients. Okay, so it needs to be the same number, and one is a positive and one is a negative. So we can simplify and solve for one variable, and then these steps are the same as substitution. Substitute that value that we got back into one of our originals, and then solve for the second. We're always going to write as an ordered pair, and we're always going to check our answers. So we're going to look at a couple of different ones here. Remember, we're just thinking like elementary school. We're thinking vertically. So I can see that my 3's and my x's are going to cancel. I get 6y equals 30, and we're just doing whatever those signs tell us. So y is 5. And then we're going to pick an original. I'm just going to go ahead. I'll pick that first one. It doesn't actually matter. 3x plus 2. My y is 5 equals 16. This is 10, so I'm going to subtract 10 because it was a positive. 3x equals 6. divide by 3, x equals 2. So my solution is 2, 5. You can go ahead and plug that in to check it. We've done that before, so I'm not going to waste your time doing that. Here's another one. My y's are going to cancel, so 3x and 7x is 10x, but negative 2 and 12 is 10. Divide by 10, x is 1. And again, choose an original. I usually choose the first one. It doesn't matter. You're still going to get the same thing. So 7 times 1 plus y equals negative 2. So I know this is 7. I'm going to subtract it because that's the undo. And y is negative 9. This last one, notice that our x's and our y's cancel. So really I get 0. I have nothing left on the left, and I have a negative 6 on the right. We've talked about this. 0 doesn't ever equal negative 6. So this is going to be a no solution. If we change these to y equals, they would be parallel. So there's no numbers we can put for x and y and get a true statement for both equations. On the back, we're going to elaborate a little bit. Sometimes it's not nice and pretty like we just saw. So in systems, if neither of our variables in the original equations have, again, opposite coefficients, so same letter, same number, different signs, then we are going to need to multiply one or both, sometimes one, sometimes both, by a constant in order to create those opposite terms. Now, when we do that, we have to make sure we multiply or we distribute on every single term. So when we look at number 4, nothing is going to eliminate. However, I do have a negative and a positive on my y's. I just need this second one to be a positive 2. So if I want this y to be a positive 2, I can multiply this entire equation by 2. Now when you do that, it's really important that you don't try to squish everything in. You need to go ahead, and I know some of you like to take shortcuts, but you need to go ahead and rewrite everything so it's nice and neat. That way we can see exactly what we're doing. So I've rewritten my first one. 2 times 4 is 8x. And then positive 2y. So now that is going to eliminate. And then 2 times 16 is 32. Now I can look at things vertically. My y's eliminate. 11x equals positive 22. When I divide by 11, I get x equals 2. Now, here's the trick. When you plug this 2 back in, you need to plug it into one of the originals, not into the one you changed. I'm going to choose the second one this time just to be a little bit different. So 4 times 2 instead of x plus y equals 16. I know that 4 times 2 is 8, so the inverse is to minus the 8. Y equals 8. So my solution, my coordinate point is 2, 8. So don't get lazy and try to squish things. When you're looking to see what to multiply by, you're looking for something that is easy. So for example here, there's not really, these are both positives on my x's and my y's are both negatives. It just depends on what you want to eliminate. I'm going to go ahead and I'm going to eliminate my y's, I think. So in order to do that, I do need one to be a positive. I want them to both be 3. But I need one of them to be a positive. So I'm going to multiply by a negative 3 because a negative times a negative is in fact a positive. So I'm going to go ahead and I'm just going to write it over here. Remember, you have to distribute on everything. Negative 6x plus 3y. Be very careful with those signs. Equals a negative 9. And I'm going to rewrite this second one. 6x minus 3y equals 9. And would you look at that? everything eliminates. So this is 0 equals 0, which is always, always true. So this is going to be an example of infinite solutions, because remember, when it's always true, we can put any number we want. This next one, we do have some positives and some negatives. However, I'm going to have to multiply both of my equations in this situation. So you need to decide if you're going to eliminate x, if you're going to eliminate y. If you want to eliminate the x, then we would need these to be 6, so it would be a 3 and a 2. If you decided you wanted to eliminate the y's, 3 and 4, 12 is going to be a nice number, so 4 and 3. Again, it doesn't actually matter which one you do. You do, however, need to rewrite. Don't squish, because then you get yourself all discombobulated. So 4 times a negative 2 is a negative 8x. 4 times 3 is 12y. And 4 times negative 12 is negative 48. And then on the bottom, I have 3 times 3 is 9x. 3 times a negative 4 is a negative 12y. 3 times 18. 3 times 18 is 54. So my y's are going to cancel. I get x equals 54 minus 48 is 6. So pick whichever one you want to plug it into. I'm going to plug it into this second one. 3 times 6 minus 4y equals 18. This is an 18, 3 times 6, so I'm going to subtract it. Negative 4y equals 0. 0 divided by negative 4 is just, in fact, 0. So our coordinate here is 6, 0. We have a little word problem down here, so let's see how that goes for us. They did give us the system. Layla is solving the system. She thinks the equations should be added together to eliminate the x's. Well, she's obviously wrong. So what should she do to eliminate the x's? Well, they're both positives, so we need to multiply one of these by a negative 1, because the signs are the same, and the numbers are the same, so we just need one of them to be negative. Multiply 1 by a negative 1. What is a possible first step? Actually, that should have been here. I apologize. Our error is that 1 must be positive, and 1 must be negative. So then we need to find the solution. So they want us to actually solve this. Again, we need to write it out. Don't squish it. So I'm going to rewrite my first one. 4x minus 2y equals negative 18. And then when I multiply everything by a negative 1, now my x's cancel. I have negative 8y, a negative 18, and a negative 6 is going to be a negative 24. So a negative divided by a negative, y is a positive 3. I'm just going to write it over here for my coordinate. And then we need to plug that in. So 4x minus 2 times 3 equals negative 18. This is a negative 6, so the inverse is adding it. 4x equals negative 12. And when I divide by 4, x is negative 3. So my coordinate is negative 3 and a positive 3. We haven't done writing yet, but they do give us the system here. So I'm going to let you go ahead. I want you to practice solving that. You are going to need to multiply one of them. You can pause me. I would like you to solve it and then play to get the solution. So you should have gotten 3 popcorn and 2 soda. I hope this is helpful. I will see you in class.